To download this file, go to the link shown on the screen and you will see the link to download the Excel file that we're going to need for today's exercise. Inside you will see information taken for different culture CFU counts at different times. You will see the 3 different culture measurements taken, and the plan is to try to analyze this information and present it in a more meaningful way. The first thing to do is look at the information itself. What type of chart will be useful to represent this information in a way that will be easy to understand? We have different measurements taken over different times, so we want to see how the CFU count has changed. So we need to plot the information. Ideally, you will be doing that with displaying a line connecting all the different measurements taken so you can see how it changes over time. So you'll need to decide between a line chart or an XY scatter plot. You have to watch the video explaining in more detail the differences between a line chart and an XY scatter plot. But basically, in a situation where the X values are along the horizontal axis, in this case we have the time slot here, if they are numerical values that should be taken into account and they're not just labels, we should be using an XY scatter plot. So we're going to use an XY scatter to show this information in a more user-friendly way. The first thing we need to do though is look at the information itself. Because it is CFU count, we are talking about huge numbers. We have here the number represented in scientific representation, and the E plus 07 means it's multiplied to the 10 to the power of 7. So we're talking tens of millions, and it gets even bigger. So it's really good idea to see if it's going to be useful to represent your information scaled down. And you can use different methods to do that. You can use a logarithmic scale, or literally just divide it by, let's say, 10 million and to represent much smaller numbers that will be easier to understand. So I'm going to show a basic one just with tens of millions scaling down. So I'm going to divide each one of those by 10 million and work with much smaller numbers. And to do that, I'll need a space next to each culture CFU count to put the scale down information. So I'm going to insert a column between B and C. So right clicking over column C, and there's an option to insert. I'll do the same between culture 2 and 3 to give me space for this scale down values. In this column, I'm going to have the culture 1 counts, and this is going to be culture 2 counts, and this is going to be culture 3 counts. The difference is this going to be in millions, in tens of millions. So in this space here, I'm going to display it all because it's going to be too much on the screen. In this space here, I'm going to calculate this culture 1 CFU count scaled down. So this cell is going to be equal to this cell divided by 10 million. 10 million is with 7 zeros, so it's 1, 1, 2, 3, 4, 5, 7 zeros. And I'm going to copy this formula down for every other measurement taken at different time slots. This information by default will be presented in the same way as the original information in culture 1, so it's going to use scientific representation, but I want to use simple numbers. So I'm going to change the way the numbers are presented just in the numbers group in Home tab, change from scientific to number. And I'm going to copy this formula into culture 2 and in culture 3 as well. And then I'm going to copy it down for every other time point. So all the information I'm going to be interested now is in these new columns that I created. I'm going to mark them with yellow so they're easily seen and there's not going to be a mistake using the big numbers. So the first thing to do is display the plot of the first culture count over time. So the information I need is the different time points and the different culture 1 CFU counts scaled down in tens of millions. To select columns that are not next to each other, simply select the first one and then press and hold down the control key while selecting the second set of data. And then go to the Insert tab and you can choose a scatter plot. I'm going to use the type that gives me the actual point and smooth lines connecting them, so I want to see the overall change. And there it is. You can see there's an increase and a slight dip at the end. So that's the first culture, but I want to add the second and the third culture to the same plot. To do that, I simply need to right click over the chart itself on the white space on the chart, and you will see an option to select data. And when you go there, you will see there's one series of data at the moment in this chart, but I want to add another 2 series of data. So going to add, and then it's asking me for the name of the second series. This is culture 2 CFU count in tens of millions. The X values along the horizontal axis here is still the same. It's still the time points, and the Y values are going to be the culture 2 CFU counts scaled down. And okay. And then I'm going to add the third series. The name I'll take directly from the spreadsheet. The X values, it's still the time slots, and the Y values I want to take from here. Series 1 doesn't have a name, so it's a good idea to change it to reflect the information that is inside, which is the culture 1 CFU count. So I'm going to edit the first series of data and just tell it that the name should be taken from this cell. You can type in the information there as well. So if I click OK, there is now the chart representing the 3 different culture counts. So I can see they are changing in a similar way, and there's a slight difference at the end of the time slot. The next thing to do is think about how we're going to summarize this information. And the easiest way to summarize this information is just to present an average as well as the information itself. So I'm going to create a new column in the spreadsheet itself that will display the average. And I want to use again the scale down values, so I'm going to create a formula here that is going to calculate the average of the CFU counts for culture 1, 2 and 3 at that particular point in time. If you don't know the formula for the average, you can just click on the FX button right next to the formula bar, and you can see there's an option here to search. And it displays anything to do with average. And you can see that this one, you can see the description here, will be the one we need. Returns the average of its arguments. So that's what we need. The average of which numbers? We don't want those. We want the scaled down count for culture 1. Number 2 is the scaled down number count for culture 2. And the third number is the CFU count for culture 3. And okay, and there's our average. And we can copy it down for all the other points in time. So I want to add this average count on the chart. So I'm going to right click again on the empty space, go to select data and add another series of data. Series name is average. The X values are still the time points. So I can go and select them from the spreadsheet, and the Y values are going to be those new averages that we just calculated. And if I click OK, and OK, it's going to display the information. So the new data series that I added, the average point, is this purple line here. but it's getting lost with all of this additional information there. So I want to trim down a bit this chart to be much clearer, to see the average clearer. To do that, I can change the type of charts that I used. I don't want to see all the lines. I just want to see the average as a line. All the rest, I want to still have them on the plot, but just represented as a little dots, little markers. So I want to change first, let's say culture 1, which is the blue line. So I'm going to click on the blue series of data here. And you will see new tab appear to the top, chart tools. And if I go to the chart tools design tab, you will see an option right at the beginning to change the chart type. So I can go there and choose to have an XY scatter. And that way I'm left with literally just the actual measurements, the dots, rather than the line connecting them as well. So I'll do the same for the second series of data for culture 2, change the type just for the scatter, and then for the green for culture 3, go and change the type, just the dots, and there it is. For the average, I need to adjust the line rather than the line and the points. So I want to change the type, this time selecting the third option, just scatter with smooth lines without the markers. So that way I can clearly see where the average changes. So this is the overall change of the data that we've collected. However, this is still only 3 different cultures and that we averaged, and it's very difficult to draw any major conclusions just from this information. One easy way to find out how we can get a more mathematical description of this change, a more smoother representation of this change over time, is to use a trend line. To use a trend line, you can choose to approximate only one series of data. So in this case, the average will be the most meaningful to approximate because it's a summary of all the other information. So I want to find if there's any way for mathematically describing this change, so potentially I could use it to calculate further data points. Simply clicking on the chart series that we want to find a trend line of, in this case this is the purple line here that represents the average, and then in the chart tools layout tab you will see the option to include the trend line. So if you click on it, you will see a lot of different options, but if you click right at the bottom where it says more trend line options, it's going to give you a choice to pick what type of trend line. The default is to show you a linear trend line, so the overall direction of change. This is quite crude because you can see clearly that the data is not changing in a linear fashion. But if you need that, the default option is linear. A measurement of how good a fit the trend line is to the data itself is r squared, where r squared varies from 1, which is like 100% match, to 0, which is basically 0% match. And you can see the r squared measurement by simply clicking at the option at the bottom of this dialog box. And in this case, even the linear trend line gives you a match of 0.9576, which is more than 95% match. So it's not bad, but we can see that the information actually is not linear. So instead of using a linear trend line, we can try a polynomial. And by changing the order, you can change the curve and you can change this trend line. If I go to the power of 3, that means the equation representing this has x to the power of 3. It gives me an r squared of more than 99%. So it's a really, really good match. It is important to think about what actually this trend line is representing. At the moment, what you're trying to find is the closest match of a mathematical function to the data you're observing. But this can only be used in terms of the data that you've actually collected and anything within that range. There is an option to forecast forwards or backwards, to estimate based on this new mathematical function where the data could go if you had extra information, for example, another hour or two in time. So just to illustrate a point, I'm going to forward it with 2 periods. And you can see immediately that it added another 2 hours to our timeline, and it continued this function. And this function is now showing that after the point that we've actually taken the measurement, we're going to have very quick decrease in the CFU count, which specialist is saying basically that's not the case. It doesn't behave like that. So this is another illustration when even when you have a 99% match of the trend line on the observed information, when you're forecasting, it doesn't mean it's going to forecast correctly. So this is not a good idea to use the forecasting unless you know how the data should behave and you can see if the forecast of the trend line behaves the same way. So in this case, we're going to stick with the information that we have, and we're going to use this trend line within this range, within the range that we actually have measured. And the way to use this is really to know the equation that describes this change. So potentially we can use this equation to calculate any point that is in between our measurements. We have taken measurements every half an hour, but we can use this function to say what with high probability would have been the CFU count at a point where we actually don't have a proper measurement. For example, 1 hour and 15 minutes after you started, which we don't have a real measurement, but we can use the equation to calculate what could be. To find out the equation of the trend line, I have to simply click this option within the dialog box saying display equation on chart, and it will show it. The chart may become a bit too cluttered, but you can move the r squared value and the equation further away from the trend line itself. And you can see it's not an easy equation, but it is a way for you to calculate a potential CFU count that you're missing. All you have to do is replace the x with the time points that you need and calculate this, and it will give you what the y value would be, what the CFU count would be. So I'm going to close the trend line. Another useful information that you can add to your chart that will give you a bit more insight for the data itself, what the data is like, because at the moment it's getting a bit too cluttered. So if you have, for example, 10 or 15 different cultures that you're trying to draw conclusions from, you wouldn't plot them all because the entire chart will become just a mess of dots. What you can do instead is present the average and the standard deviation, how much the data varies from this average. The easiest way to do that in Excel is by using error bars. And the error bars can be representing a lot of different information, but they're literally little bars that are appearing at every point in time, in this case in time along the x-axis, and you can specify how large they are. You can use them to show, for example, minimum and maximum values, but the more meaningful one for the data itself would usually be the standard deviation. So in order to create the error bars, we need to calculate the standard deviation that will be represented in the error bar. So I'm going to move this chart away and squeeze a bit this information to have a bit more space on the screen. And I will create another column here that I'm going to use to calculate the standard deviation. Again, you don't need to know the formula for the standard deviation. You just click on the FX and you start searching. And you will see all the results. If you're not sure which one, just click through all of them and read the description. We're going to use the standard deviation of a sample. So I'm going to click OK. And then I need to tell it standard deviation of which numbers. Standard deviation of the first culture CFU count, standard deviation the first, second and third value. Remember, we have to always use the same ones, the same scale. So the standard deviation between the different measurements I've taken between the different cultures that I have. So if I click OK, it's going to display the standard deviation, and I can copy the formula down for all the other points in time. The way the error bars work is that you can represent different information in the top half and the bottom half of the error bar. So the point that is above the points of measurement and below the point of measurement. And I want the entire bar to represent the standard deviation, which means the point above the little dot on the chart itself will be half the standard deviation, and the other half will be below it. So the overall error bar, the top and the bottom half, will be the total standard deviation. So that means I need to calculate half of the standard deviation. So I'm going to use here half the standard deviation, and I can simply say it's equal to the standard deviation divided by 2. And then I can copy the formula down. So there's the information that I want to use within my chart. So I'm going to make it much bigger. And I want to add the error bars now to this chart. I need to add them to one series of data, and it makes more sense to add them to the average because they're showing the data spread from this average. So I'm going to click first on the average data series on the chart itself, and then from the chart tools layout I can choose to add error bars. And again, I'm going to go to more error bar options and choose what information I'm going to present in these error bars. I don't want them fixed value. I want to specify myself what information goes in this error bar. So I'm going to choose custom option so I can specify the values. If I click on the specify value, it's going to give me a choice to pick what is the positive error value, what is going to be the amount shown above each point. So I'm going to delete the default one. I'm going to choose to display half my standard deviation on the positive side, and the other half is also represented this time in the negative. So the positive and the negative should represent each of them half the standard deviation. So if I choose to close, these vertical lines here are representing the standard deviation that I have chosen. For some reason, by default, it will always add a horizontal error bar. Please delete it. All you have to do is click once on one of them, and that will select all the horizontal error bars, and you can just press delete on the keyboard to remove them. And you can see now the error bars that you have added that represent the standard deviation. And you can see it's quite a small standard deviation at the beginning. There's slightly bigger value here, and it increases over time. And if you look at the data itself, that's exactly the case. So this type of information will be a lot more meaningful to look at. And again, this is not complete. You have to make sure that you have labels on this chart. So I'm going to add them quickly. I'm going to go to Chart Tools Layout, Axis Titles, horizontal one. I want to add that this is time. Time in hours. And the Axis Titles vertical rotated shows the culture CFU count in tens of millions. So this is a lot more meaningful information that you can use. In order to use the equation itself to calculate points that you actually don't have the real values, you'll need to translate this into formulas that Excel can understand. This is the normal human expression of mathematical function. This is the way you would calculate it if you have to do it. But Excel doesn't understand this. If you want to calculate it in the way Excel can understand, you'll need to write this entire formula in a way that Excel calculates. And I'm going to show you how this is done, and you can try it in your own time. So the equation you got from the trend line needs to be converted into a formula that Excel can actually understand. I have written the equation as it was displayed in the chart itself, like you would write it normally if you have to calculate a mathematical equation. However, when translated into the way Excel understands it, it looks quite different. The first part, you can see we have negative 18.818 multiplied by x to the power of 3. And the way for Excel to calculate this is using the integrated function power of x, comma 3, which for the computer means that this value here, whatever x is, will be cubed. And when you type it in Excel, instead of x, you'll need to type in the cell where the time slot will be contained, where the point that you want to calculate about is going to be. So the next part of the equation is plus 175.42 x squared. The same way you have plus the number multiplied by power of x, comma 2. The next element is minus 162.8 times x, which we can do a simple minus 162.8 multiplied by x. Obviously x should be replaced with the point where the information is stored, and plus the final component, which is just a number. So if you have to write it in Excel, it will look like this at the bottom here. And let's see how it's going to work in Excel. I'm going to use a space here to the side where I'm going to put the information about the time. So in the cell here, I'm going to be entering at what time I want to calculate the CFU count, the projected CFU count. And in here, I'm going to hopefully get my CFU count. So in this cell, I want to have this equation that will take whatever value is here and calculate it. So I'm going to paste this information, and I need to replace x with the cell K17 in this case because of where I clicked, K17, and this x is also K17, and this x is K17. I have used this cell here to be the value x, the time that I want to calculate the CFU count for, and used this formula written in the way Excel can actually calculate it to estimate the CFU count. So if I press enter now, it's going to give me a point at 0 because K17 will be 0. But if I put in additional points, for example, I want to calculate what would be roughly at, let's say, 2:15, which would be 2.25 in time, because a quarter of an hour is a 0.25 an hour. The CFU count, according to our trendline estimation, would be 358 almost. So just going to give a rough idea from here. So just after 2, it's going to be around here, which looks like it's close to the point above between 200 and 400, so 300 and something. So it looks like a value that could be real. So this is a quick check to see if your point actually is presenting nicely along the trend line. So in summary, whenever you have information that is way too detailed, you have to find a way to present it in a more summarized manner. The easiest way to do that is using graphs. And if you have to look for an overall pattern the best way to do that is using averages and standard deviations to see how on average how it changes and how spread around your data is around this average. And if you need to have the mathematical description of this change, a trend line is a really good way to find out which function will approximate best the data you have collected. So you can do the trend line, find out the equation from the trend line, and then potentially use this equation to estimate what your CFU count would have been at a point where you don't really have a measurement.